questions, mass and mole questions, and so on. So this is basically the objectives for this class. So now let's begin with what stoichiometry is all about. Okay, when we talk about it has to do with, we'll see things like moles. Okay, we'll see things like mass, we'll see things like volume. Okay, stoichiometry there is about how an amount of something will require an amount of another thing to produce an amount of a. Want to bake a cake, okay, would make use of things like a flour, would also make use of sugar. Okay, so let's just say flour and sugar is what is going to give us our cake. Okay, so stoichiometry is helping us to know how, in terms of this baking now, how much of flour and how much of sugar we are going to combine to give us some cake. So if we want to use chemical elements now, or let's put it now in the chemistry way, okay, so let us say something like H2, okay, plus oxygen to give us H2O. Okay, so when we do something like this, we have to balance this to be like this. So this is telling us that we need 2 oxygens. This is the amount now, the mole, these 2 here, okay, to react with 1 oxygen to give us 2 water. So it's more like saying 2 moles or 2 amounts of hydrogen molecule with 1 amount of oxygen molecule, it will give us 2 amounts of water. So it's like the qualitative study of how much of reactant will react to give us our desired product. That is what stoichiometry is all about. Okay. If you are following and if you understand so far, I want to see a thumbs up. I want to believe that Uyosa, Wina, and Lucas, the 3 of you are chemistry students, right? Oh, Winners is chemistry student. I already know that. Uyosa and Lucas. Okay, Lucas is a chemistry student. How about Uyosa? Okay. So since you are chemistry students, at some intervals, I might be calling your name and asking you questions. So let us follow through. So I intend that this class will do more of examples, because when we talk about stoichiometry, you would hardly see exam questions that are all about define this, define that. Okay, the highest thing that could happen is you being asked to state the law of conservation of mass, or of constant proportion, of multiple proportion. But the bulky aspect of this topic is calculations. Okay, so we'll be doing more of calculations in this topic rather than defining terms and explaining what is this and what is that. Okay, so now when we talk about law of conservation of mass, we are talking about how much of reactant will give us products. Okay, so that is to say, just as the example of this water that I gave initially here, it's telling us that the total number of, when we see this equation, okay, the elements we can pick out from here is hydrogen, and we can also pick out oxygen. So hydrogen and oxygen are what is participating in this whole equation. So the total amount, okay, or the total mass of hydrogen and oxygen in the reactant must be equal to the total amount or mass of hydrogen and oxygen in the product. That is what law of conservation of mass is telling us entirely. So it's more like, it's the same thing as having an equation and being able to balance it, such that if you're having 4 hydrogen altogether in the reactant, it must be 4 in the product. Or if you're having and if you're having 2 oxygen in the reactant, it must be 2 also in the product. That is, the total mass in the reactant is conserved in the product. Okay, so when we talk about mass here, we can check that by figuring out what is the molar mass. We know there's relative mass or molar mass of oxygen, which are usually the same number. Okay, so since oxygen is 2 in the reactant, okay, and then we have the relative mass of oxygen is 16, so it's times 2, which is 32. Okay, in the product we also have 2 oxygens, which will also give us 16 times 2, which is 32. So there's nothing is lost. The total mass in the reactant is the same mass that we see in the product. So that's what law of conservation of mass, that is what the law of conservation of mass is simply telling us. Okay, so when we see this first question, which of them obeys law of conservation of mass, it is what the first answer. Okay, so now the empirical formula of a compound CH2, of a compound is CH2. If its molar mass is this, the molecular formula is equal to what? Now, when we are dealing with, I believe empirical and molecular formulas are what we have already been taught. Okay, so things like these are things that you can do on your own, but let us look at it together. I hope everyone is following me. Okay, all right. So for us to be able to get the molecular formula, we know that empirical formula tells us the ratio of one element to the other. Okay. Then from the empirical formula, we can solve it to be equals to 28. Okay. Where we would now have carbon to be 12. Hello, can you all see my screen?
No.
Oh. Please excuse me, let me reshare. I believe you can all see it now. Melody, can you see my screen?
Yes, ma'am.
Uh-uh. Okay. So now how do we so we know the relative mass of carbon to be 12. Okay. Usually it's a number that would sometimes be given to you, but if it is not given to you, it's usually double of the atomic number of the element. Okay. Except for hydrogen. Hydrogen is sticking with 1. So we have this carbon plus hydrogen, which is 1, the relative mass. So we don't really have to memorize the relative mass of every element, but there are some elements we just have to know, okay, in case it's not being given in the question. So elements like for carbon, for chlorine, for oxygen, for hydrogen, sodium. Okay, so these are um, common elements we deal with. Also nitrogen. Okay, carbon is usually 12, 35.5, 16, 1, 23, and 14. So I believe these are all the common ones. If there are any other one, it will usually be given to you, the relative mass. Okay. And okay, so from here equals to n, and then we have 28. So you remember this hydrogen, the relative mass is 1, but then we have 2 hydrogens here, so it's going to be times 2. So this is going to be 12 plus 2. So this is going to give us 14. So n is going to be, by the time 28 divides 14, we're going to have 2. That is to say, for each of them, okay, the number is 2. So carbon is going to be having, so this old formula now, this old formula is now going to be rewritten like this. CH2, right? N. And now we have found N to be 2. So it's going to be CH2N. So it's more like going to be C2H4. Please, if anyone is confused, let me know. Or if you have any question. So this molecular formula is now going to tell us what exactly this compound is. Okay, so if you've done organic chemistry, when we solve for molecular formula and we get this C2H4, okay, we see that this is ethene. So we can call this ethene, or we say this is the molecular formula of ethene. But what empirical formula tells us is just the simplest ratio. Okay. Okay, no question. Now the next question says, which type of reaction is represented by this? Now, like I said earlier, we said synthesis reaction is about how a particular compound can be formed, okay, through the reaction between 2 or more compounds or 2 or more elements, okay, while decomposition is where a single reactant will break into 2 or more simpler products, okay. So that is easily what this reaction is carrying out. Now, I said also combustion involves burning, okay? Involves a particular compound reacting with oxygen. So these compounds are usually hydrocarbons, that is carbon and hydrogen compounds. And that is not the case here. We cannot see any burning. We cannot see anything, let's say XYZ, reacting with oxygen to give us carbon dioxide and water. When you see things like this, when something's reacting with oxygen to give us CO2 or CO and water, okay, we say that's combustion, but this is not the case. And like I already said, the composition is a particular reactant will be broken down. Okay, so that is easily what is going on here, because we are saying that our reactant is only one. So we can represent the composition reaction like this. A will give us, okay. Then displacement is maybe two or more reactants will be reacting. One with probably higher priority than the other will displace the other. Okay, so for example, let's say sodium, okay, plus zinc. Okay, so a reaction like this might occur, and then because sodium has more priority or is more electropositive than zinc, what would happen is it can displace zinc, okay, and form a reaction with sodium 2SO4, and then zinc will be on its own. So this something like this is how um, displacement reaction occur. Okay. So now the next question. The next question, 1 mole of a substance contains how many Avogadros? So in a single atom, okay, one atom, hello? Okay. A single atom has Avogadro's explains that one amount of something is equal to 6.02 times 10 to the power of 23 atoms. Okay, or times 10 to the power of 23 particles. So the amount of something can be the mole of something, or an atom of something has these particles, or the mole have these atoms. So it just depends. At the end of the day, is one amount of something. So we can even say one amount of water, H2O, for example, okay, or 1 mole of water contains how many particles? Okay, I can see someone's hand is up. Do you have a question, Mr. Luther?
Yes, yes, yes. Just trying to call Melody. I think I can see Melody here. Melody, they say something about avocado's number. What does it represent? Lucas. Lucas. What's his name? His name is Eze. What is avocado's number? The teacher just mentioned it now. What does it represent? What's the value? What's the constant about? Efosa. Efosa, are you there? Efosa, are you there?
Sorry, I was busy.
About one, oh, yes.
Okay, it
Busy.
represents the amount
While in
of
class.
particles in 1 mole contained in a mole of any substance.
Okay. Obawoni. That's a winner. Is it Obawomi? Yeah, I think so. Winner, are you following?
Stop it, I just joined the class. My network is bad.
You can carry on, ma. You can carry on.
Yes, I'm hearing you. So I said my network is bad and I just joined the class.
Okay.
You can go ahead, ma. Yeah, you can go ahead. Yeah.
All right. Okay, so the next question says, what's the molar mass of, okay, when we see things like this and we see all these values in brackets, these are telling us the molar mass of each of um, each elements that are present in this compound. Okay, so we say H is 1, and we have 2H. Then S is 32. Okay, and then oxygen, we have 4 of it. This one is 1 of it. So telling to know the molar mass, if the molar mass of hydrogen is just 1, okay, then since we have 2 hydrogens in the compound, the molar mass of hydrogen in the whole compound will now be 2. If the molar mass of oxygen is 16, if we have 4, 5, 10 oxygen in the compound, that means it's going to be multiplying, the 16 will be multiplying that total number of oxygen. Okay, so to solve something like this, we would have, for hydrogen is 1 times 2 plus SO4, which is 32 plus 16 times 4. Okay, and then when we add all of this together, okay, that's 98, which is the option B. So what if we have something like this? Someone should tell us the molar mass for this. Nitrogen is 14, hydrogen is 1, sulfur is 32, and oxygen is 16. So I believe every one of you have your notebook, pen, and a calculator. So someone should attempt this, or in fact, every one of you should attempt it, and let's see who will be the. I'll be giving just 2 minutes for that, even though 2 minutes is quite too much time.
34.
Is what?
84.
84.
Yeah.
So tell us how we got 84.
So let's go to ask molar mass of 14, while hydrogen has
Mm-hmm.
molar mass of 13. So we multiply 3 times 1. So we have 3. So ammonia is having us together to multiply 2 times oh yes, we multiply 2
Mm.
times 3. So we use that to test nitrogen, that is 14. So 14 times
So you are
2
saying, sorry,
is
sorry, you are saying nitrogen has 14, right? Then hydrogen has 3.
yeah,
So we'll now get
yes,
17, right? Mm-hmm.
yes. 17 times
So what
2.
what's the next thing you did?
So 17 times 2 is 34. So write that 34 down. So we focus on SO4. So S have 32 molar mass. So oxygen has 16. 16 times 4 will give us 64. So 64 plus that other one give us 130.
Okay, plus 32 plus 64. Is that what you did?
Yes,
Hello,
yes.
winner. Is it winner? No, melody. So all this together, is it no more than the 87 you gave? Hello?
It's more than that.
Okay, so what's the total no answer that you got? Which one is now your answer? Is it the 84? Or is when you add all of this together? When you have add all of this together, that's a 64 plus 34 plus 32.
If you
Six,
add all
seven,
of
eight,
these two
nine, 10,
together,
11, 12, 13. Yeah. Hello? Okay, so this is what is going to happen. We know the melody, are you there? Okay, we know the molar mass
Yes,
for
ma'am.
nitrogen is 2. There is 14, but then this 2 means that we have 2 nitrogens. So it's going to be 14 times 2. So first off, this is going to give us 28. Now hydrogen there is 6 because this is going to give us 3 times 2. Okay, so this is 6. Then our sulfur remains 32, and our oxygen is 16 times 4, which is going to give us 64. So when we add all of this together, okay, this plus this plus this plus this, okay, it's also giving the same number like you got. So you got it rightly, Melody. It's not this 84 that you got the first time. So in essence, every number inside a bracket, you have to consider the subscript after the bracket. You multiply it by what is inside. Now the next question says, I hope every other person understood. Now, based on Avogadro's, if we see this question here, because we have dealt first with Avogadro's number. Now, when we see this question, this is actually a past WAEC question. Okay, so let us attempt it. We already defined what Avogadro's number is. Okay, as the number of particles in 1 mole of a substance. One of you has already said that. Now, the next question says if 2.3 gram of an oxide of nitrogen contains this mole, calculate the molar mass of copper. Okay, this question doesn't look complete. Now the next question says determine the mass of copper deposited if electrons in reaction represented by the equation below. Now, one other thing that we have to take note of is some certain formulas like number of moles. Okay, number of moles can be related to the coefficient of a balanced equation. Okay, and number of moles is equal to the mass of a substance divided by the molar mass. Okay, so now we are looking for the mass of copper and we are given the number of moles to be equal to 4. And this is the balanced equation. Let me rewrite it. We have copper 2 plus iron plus 2 electron lost to give us copper solid. Okay, so based on this equation, 2 electrons is being lost. Okay, and in this kind of question, we have to also know the molar mass of copper. And the molar mass of copper is 63 gram per mole. Okay, so um, if we're going to look for the number of mole, it's going to be our no, we're actually looking for the mass, not number of mole. Determine the mass of copper deposited by 4 moles, okay, of electrons represented by the equation below. Okay, and our molar mass, or capital M, is equals to 63. So our mass is going to be number of mole times molar mass. Okay, but when we see this particular question, we notice that it is 2 electrons, okay, that is being given off. But the question is asking for 4. Okay, so to get our mass, our number of mole based on the balanced equation is going to be 2 times 63, which is going to give us 127 gram. Okay. Do you all understand? Hello? Does everyone understand? Oh, please let me reshare my screen. Okay. Please, can you see my screen again? Can you see my screen? Please, I need response. I need response.
Yes, yes, concede.
Okay. Now let's see um, the section B of these other questions. Okay. Now the first question says, what is a mole? And what is empirical formula and two laws of chemical combination? The laws of chemical combination, what we have said earlier on. Okay. We mentioned conservation of mass, definite proportion, um, and so on. Now for what a mole is, okay, we can define mole as the amount of substance contained in 6.02 times 10 raised to the power of 23 particles, okay? So that is a definition based on Avogadro's, okay? And then the next one says, what is empirical formula? Okay, so like I said earlier, is the simplest ratio. Okay, it's the simplest ratio of all the constituents of a particular compound. So we can simply or better put it as is the simplest whole number ratio of atoms of each element, okay, that are present in a particular compound. Okay, the simplest ratio. So for the laws of conservation of um, laws of chemical combination, we've already mentioned that to be of different elements. Oh, different elements that makes a compound. Okay, and mole can be seen and the amount as the amount of particles, or rather no, of substance containing 6.02 times 10 to the power of 23 particles. Okay, the particles can be atoms, molecules, or ion. Okay, and here we can have the law of conservation of mass, law of constant proportion. Okay. Now in balancing, we're asked here to balance the equation. You see, well, one of the rules in balancing chemical equation is you don't change the subscript. You can only add to the coefficient. The coefficient is the big number that stands in front of every element, like this 2, for example. Okay, so in order to balance this ion, for example, we would not come here to write down 3 here. We would not come to write down 3 so that the 3 will be the same with this other 3. No, that is not how it's being done. We can only alter the coefficient. We don't alter the subscript that is already there. So for us to write how many to balance the ion, what we would do is to write 3 ion here. Now our ion is balanced. Now how about hydrogen? We have 2 hydrogen here and 2 also in the product. So our hydrogen is also balanced. But then our oxygen is 4 in the product, but it's just 1 in the reactant. And we can't come and be adding anything here, maybe adding 4 here. Because when we add 4 here, we are creating a new substance, a new compound entirely. This is no longer going to be water. Okay? And even if we add 2 here, we are also still creating a new compound. But then if we alter the coefficient, we are only increasing the amount of water. We are not changing the fact that it is water. So that is why we can only alter the coefficient to be 4. And then when we put down 4 here, we are also affecting the hydrogen. So hydrogen is now no longer 2 in the product. In the reactant also, it's no longer 2 rather in the reactant. So in the reactant is now 8 because it's 4 times 2. Subscript and coefficient will multiply. Okay, and so for us to balance it in the product, we'll do likewise. So rewriting this, we're having 3 ion plus 4 water to give us ion 3 plus 4 H2. Now our reaction is Our equation is balanced. Now the next question is asking us what is a standard solution. Okay, a standard solution is a solution whose concentration is known. You must have done titration reaction at school, right? So there are some there is the solution that the concentration is known, and there's the one that the concentration is not known, and so that's why you have to carry out an experiment and you have to do some calculations so that you'll be able to know um the unknown concentration, so that you'll be able to determine it. So a standard solution are solutions that will already know the concentration of it. That is how much of it is dissolved in the solvent. Okay, if it's or okay, that is how much of it is dissolved in the solvent. That's what simply it's all about. Now, primary standard is a pure and stable standard solution. Okay. Now the next question is, what is concentration? Concentration is the amount of solute per unit volume of a reactant. So in simple explanation, concentration is more like we have this jar or this cup, and it is containing water. Okay, that is the solvent. And then we'll pour in it acids, let's say HCl. Okay, so we can talk about the concentration of acid. We'll talk about the concentration of acid in this water. We are talking about how much of acid is in this water, the amount of it. Okay, so that is why when acid is already mixed up with water, we can say it is now less concentrated because the water has diluted how much of it, the amount of it. Okay. Then the next question says we should calculate the concentration when 5 grams of sodium chloride is dissolved in this volume. So one thing is calculations. There are much formulas in this particular topic of stoichiometry. Now, one thing we should notice is that concentration is in gram per dm cube. This alone can tell you what the formula for concentration is. Gram there is the unit for mass, and then dm cube is the unit for volume. And then now this pair, this minus 3 that is the power, is telling you there is a division going on there. Okay, so this is now the formula for concentration. Mass divided by volume. Now, another thing we can notice in this question is that the concentration is gram per dm cube, and then the volume given us here is 500 centimeters cube. This is contradictory. Okay, so we have to stick with one volume because this dm cube as the unit of concentration was given by the volume. So we can't have dm cube and we can't have centimeter cube in one single question. So we have to stick with one unit. It's either we are using dm cube or we are using centimeters cube. But then the question says we should make our concentration to be in dm cube. Okay, so that is to say our mass is already in gram, so it's going to be 5 divided by volume. Before we would use this 500 centimeters cube volume, we should convert it into dm cube. So we should always be looking at our units whenever we are solving mass volume relationship, anything concerning stoichiometry. Okay, so we should know that 1 dm cube, which is also 1 liter, is equals to 1000 centimeters cube. So this is a conversion that we should know at the back of our minds. So if that be the case, if 1 dm cube is going to give us 1000 centimeters cube, then how many will give us 500 centimeters cube? What we can do here, let's eliminate this, is to cross multiply. So when we cross multiply, we would have 500 centimeters cube is equal to 1000 times the unknown, which is a question mark. So for us to have just the unknown, we'll be multiplying through by 1000. 0 cancels 0. So we now have 5 divided by 10, which is equal to 0.5. So our volume is now 0.5 dm cube. Now we can divide properly and get our accurate answer. Now when we divide this, we would have 5 divided by 0.5, which is going to give us 10. So this is now going to be 10 gram per dm cube. I hope no one is confused. Do you all
I'm
understand?
confused.
You are. Which one? Is it this particular one we just did?
Yes. From 1 dm equals to 1000 cm.
Okay, I was basically just converting there. But let me explain again. Now I said the question asked us to that's question 4. Okay. The question asks us to find the concentration, and the unit is being given us here, gram per dm cube. When 5 gram, whenever we see 5 gram, when we see gram, we know they've given us the mass. So our mass is 5. Dissolved in 500 centimeters cube. Centimeters cube there is telling us they've given us the volume. So our volume is 500 centimeters cube. Now, but then the question is asking us for concentration. And what is the formula for concentration? This is something we should already know, okay? These are formulas we should memorize. But then in this question, they actually kind of sneaked it out to us because they said our concentration should be in gram per dm cube. And I believe you've been taught maybe in physics or so how to derive formula from their unit. So this is telling you that gram, this is the same, this gram per dm cube is the same thing as gram over dm cube, which is mass, gram is mass, and dm cube is volume. So now we can say the concentration, the formula for the concentration is mass divided by
I'm not seeing
volume.
your I'm not seeing
Now
your
the
screen.
really um I can actually see it from the phone. Have
It's not
you
I'm seeing
like
it.
can you see it now? Okay. So now we say concentration is mass over volume. But take note because your question says your concentration should be in gram per dm cube. Now the mass that is given to you is actually in gram. That is good to go. But the volume that was given to you is not in dm cube, and we cannot have dm cube and centimeters cube in one question. We have to stick with only one because both dm cube and centimeters cube are units for volume. We can't have two units in one question. It's going to contradict our answers. Okay, so since our constitution must be in dm cube, that's what they say we should calculate it in. We now have to convert the volume given to us, this 500 centimeters cube, to dm cube. And based on mathematical conversion, 1 dm cube is equivalent to 1000 centimeters cube. Okay, so now what I was doing there was basically showing you how to derive it, because if one dm cube will give us 1000, now we are looking for how many will give us 500 centimeters cube. So it's more like writing the dm cubes in one side, the centimeters cube in one side, then we'll compare. How do we do this comparison? By cross multiplication. Because some
Ma, please,
persons
I'm
will
not
just go
seeing
ahead.
it.
You can't see it. How about now?
Maybe it's your network.
My network.
I
But you
mean,
can
that
hear me
I'm talking
clearly.
to me. I can see it now.
Okay, it's winner. Okay, so from here, for us to know how many is 500, if one is 1000, how many would now be 500? We will cross multiply. And when we cross multiply, the unknown will multiply 1000, then 1 will multiply 500. So we are now having 500 equal to 1000 unknown. Since we are looking for the unknown, we'll divide both sides by 1000. So it's just like a deriving, we wait to derive it. So 0 cancels 0, 0 cancels 0. So it's now going to be the 5 divided by 10 is equal to the unknown. So the unknown is now going to be 5 divided by 10, which is 0.5. So now we have now gotten our proper volume. Our proper volume is not 500 centimeters cube, but it is 0.5 dm cube. Okay, volume is equal to 0.5 decimeters cube. Okay, so now to solve our concentration, we'll have equal to 5 divided by 0.5, which is 10 gram dm cube. So assuming we just use that 500 centimeters cube like that, we'll get a wrong answer. So we should be double checking our units. Melody, do you understand it now?
Yes, ma'am.
All right, now the next section. Now, a compound contains this of carbon and this of hydrogen. Determine the empirical formula. We should have done this before. That's molecular formula. Okay, but let's do it. So there are some steps to finding empirical formula. Okay. Okay. So this question, if you look at it very well, is very much related to the one we did earlier, right? Because when we look at this, they said it is 24 grams of carbon, and that is the mass of the carbon. But we know that the mass of one carbon is 12. So this 24 is double of 12. So in essence, for this empirical formula, we're having two carbons. And then for hydrogen, we know that we are having two carbons. For hydrogen, we know that the mass of hydrogen is just one. The relative mass is just one. And then, but in this question, we are seeing four hydrogen. Okay, so that is to say we have four hydrogens together. So the empirical formula for this would be like C2H4, but it's the simplest ratio. So this is not yet in the simplest form. Okay, so this is going to be CH2. Okay, because we know that one of the way we normally, or the way the method you normally have been taught to look for empirical formula is to first divide the the elements by their atomic mass, right? But in this question, we're not giving the amount of each element in percentage, okay, or the total mole. We have already scratched that first step. This is now the second step. And then to look for the molar mass, we have the molecular formula from the molar mass. We already did this earlier on. The question two, the number of moles in 4 grams of CO2. 4 grams of CO2. We know number of moles, again, that formula. Number of moles is equal to what? Mass over molar mass. Okay, now we see that the mass is giving us at 44 grams. And what is the molar mass for CO2? Carbon is 12. Molar mass of oxygen is 16 times 2, which is 32. So this is still going to give us 44. So our number of mole is just 1. 1 mole. So how many molecules are present? So what they're asking now, how many molecules are present in 1 mole of CO2? What do you think? Someone should tell us the answer to this question. We know that the number of mole, the amount is 1. So how many molecules, how many particles are in this one amount? So it's more like when we have calculated, we find CO2 to remain CO2. So this substance now, how many Avogadros? How many Avogadros are in this one substance? Someone should tell us the answer.
Ma, please say the question again.
I said we were first asked what is the number of moles. We calculated the number of moles to be 1. Okay, that is the number of mole in 44 gram of CO2 is equal to 1. Now they are now asking how many molecules, or rather how many Avogadro's number are in this one CO, in this one mole. Did you get the question, Melody? Efosa, Lucas, you people should answer. Okay, I think it's Lucas that answered the last one
Your
also.
network is
Was it
very bad.
my network?
Ma, the answer.
My own.
Okay, okay. Okay,
The
Melody,
answer. The answer is 6.02 times 10 raised to the power of 23.
very good. Because it's just still one more. So one of this CO2 is still going to give us the same number of particles. Assuming we got our answer to be 2, then that means we are now talking about 2 moles of CO2. Okay, so in that case now, the number of molecules that will be present in this 2 amount of CO2 will be 2 times 6.02 times 10 raised to the power of 23. So we are now going to be getting a different Avogadro's number. Okay, if we had 3, it will now be 3 times this. Okay, and so on. Now the next question says, given 2H, given this reaction, 2H2 plus oxygen to give us water, calculate the mass of water produced when 4 grams of hydrogen reacts completely. Now in this question, calculate the mass of water. We do not know the mass of water, okay? But then we know the mass of hydrogen to be 4, okay? But how do we get the mass of water? Mass of water, if number of moles is equal to mass over molar mass, the mass will be equal to number of mole times molar mass, right? So now, for us to be able to get this mass, we need to know what the number of mole is and what the molar mass. The number of moles was not given to us in the question, okay? But then the mass, the molar mass is something we can get. We can determine the molar mass of water, okay? Water is H2O. Sorry, please excuse me, let me erase. Water is H2O. So molar mass of H2O is equals to 1 times 2, which is for hydrogen, plus 16. Okay, so this is going to give us 18. So the molar mass of water is 18. But we still don't know the number of mole of water. Okay, for us to be able to get the mass, which is the ultimate thing the question is asking of us. So how do we get the number of mole? We don't know both number of mole and mass. So for us to get the number of mole, okay, is for us to use the mass of hydrogen to get the number of mole of hydrogen, so that we would use that with the balanced equation to get that of water. Now, when we are given a question like this, we should know that the coefficient is not the same thing as number of mole. but we can relate coefficients to number of mole for us to be able to get our number of mole of the unknown substance. Okay, so now this balanced equation tells us the question. You see, in the question we are dealing with water and hydrogen. Nobody talked about oxygen in the question, so we are dealing directly with the relationship between hydrogen and water. And between hydrogen and water, you see that 2 hydrogen gives us 2 water. So the ratio is 2:2, or we can simplify this and say it is 1:1. Okay, that is to say for every 2 hydrogen, we will form 2 amount of water. Okay, so for us to find the number of mole of water, remember this is mass of hydrogen. Let me write it well. Mass of hydrogen. Okay, now number of mole of hydrogen will now be the mass, which is 4, divided by the molar mass. The molar mass is 2 because we are dealing with hydrogen molecule, not just H, but H2. Okay, so divided by 2, which is giving us 2. So the number of moles is equal to 2. And you see in the question, in the balanced equation, the relationship between number of mole and water is 1:1, 1:1 between hydrogen and water. So if now the number of mole of hydrogen is 2, that means the number of mole of water will also be 2, because their relationship based on the balanced equation is a 2:2, which is also the same thing as 1:1. So it's more like saying if it is 1 to the ratio of 1, then 2, this is hydrogen and this is water. Then 2 hydrogen will also give us how many? We can still do cross multiplication here. Okay, which will give us equal to 2. 2 is equal to the unknown. So the unknown is still 2. So that is to say, number of mole of water, number of mole of H2O is also equals to 2. So now for us to get our mass of water, we'll go back to our equation here. Okay, mass is equals to number of mole, we have discovered it to be 2. Molar mass, we have discovered it to be 18. So 18 times 2
Mom,
is,
mm,
you said?
I say I'm not seeing your screen.
Oh. Can you see it now? Winners, can you see it now?
Yes.
So our mass of water is 32. Okay, 32 grams. Winner, not winners. Melody, do you understand?
Yes, ma.
Okay. All right. So please, if you have questions, you can start asking now, based on what we have done so far. So today we had Lucas in class, Efosa, Melody, and Winner. Um, what's his name? Efosa. Okay, Efosa is female. Please unmute your mic and tell us what you've learned today.
Okay. I learned about the molar mass, the how to calculate the molar mass of some for compounds, that the molar mass is calculated is the SI unit for molar mass is grams. That's what I learned.
Okay, it's gram per mole. But relative mass can be gram when you're relating it with the mass directly. Okay, that's all you learned. Okay, so let me ask you, what would be the molar mass for oxygen? Efosa, what's the molar mass for oxygen?
Um, I'm coming. The molar mass of oxygen, I think, is 16.
Okay, it's 16, even though you're not sure yet, you think. All right, so that's correct. That's good. Lucas, unmute and tell us what you learned today. Is Lucas there? Okay, winners, tell us what you learned today. Melody, over to you. What did you learn today?
I learned that how to calculate the mole of the substance.
Okay, so how do you calculate the mole of a substance? What's the formula you use to calculate number of mole of a substance? Huh? Yes, winners. What's the formula you use to calculate mole? Is that you learned how to calculate number of mole? What formula can we use to calculate number of mole? Okay, Melody, tell us. Seems like winners is not.
To calculate the number of moles, we is mass over the molar mass.
Very good. We have for today. You guys have done well to have come for class today. So, I hope everyone actually learned something. If there are questions you would want to ask, you can ask them. You can also keep them for the next class so that the class that would be having next, you come prepared. So our next class will be in organic chemistry. So every one of you, the questions you have, those challenge you have, you pile it up. Then in the classroom, you ask questions so that you actually participate with parts of the topic that was actually challenging to you. Okay, so go and study and come prepared for the next class. See you all on Wednesday. Bye bye.